And welcome to the third video in our Unity's audio stream series. Quite excited to have this video once again. And before we're starting talking about the subjects we have for this video, let's have a quick recap about what we talked in the former stream where we started to implement locomotion for the RedRunner. First of all, we talked about prefabs and the concept of prefabs and why they are so important for us, and when we should think about implementing our audio on the prefab itself, or when we just want to work with a local game object in our scene. After that, we talked about the animation events and why they are relevant for sounds like the locomotion sounds in our example, where we need something to always stay in sync with a frame. And then we started talking about C# and we took our first steps inside C#. And we talked about basic concept in scripting that is relevant for our case, and we looked at functions related to audio, and then we finished with just like calling dynamically different audio clips through one audio source, and by that actually implementing some kind of game audio thinking here about like let's use as less resource as possible to achieve the best sound design system or sound system we can achieve. And in this lesson, we're gonna take that system we built in the last lesson, and we're gonna take it one step forward, and we're gonna make it a bit smarter and a bit more elaborate to actually be way more fitting to this game audio environment. And by that, we're gonna start calling random assets for the footsteps, and we're gonna run on different parameters related to our audio source. So like in every time we're calling one of the functions, we'll be calling them a bit differently in the way we're gonna actually play the audio clips. And then we're gonna route dynamically the groups into our mixer. And we're also gonna talk about the difference between the play and the PlayOneShot function and see how we can use each to fit like our needs better and what's the pros and cons for each function. So without further ado, let's dive right in. So as I said, on the last stream, we started implementing our audio clips for the runner. Wait, let's take out the music. Let's play. And currently we're playing the running, jumping, and landing sound from a RedRunner. It doesn't matter how fast he gets, we're always gonna stay in sync, which is cool because it's our first footsteps, our first steps into actually implementing the audio for this RedRunner. But you're already probably hearing two main bugs here. First one, it is kind of dull because we're just playing one audio clip for each function here. And the player will probably quickly pick up on the fact that it actually sounds the same and it's repetitive and it's just like one asset. And yeah, it doesn't sound so good. The second thing here is that every new sound cut off the last sound. Like listening for the jumping, for example. You see it cuts it off. We're also going to address that issue and how we can actually solve this. But first thing, let's make our footsteps a bit richer and actually make sure we're playing all the audio clips we have in our game. So as you can see, we want actually our script to call those footsteps randomly. So yeah, let's do that. So let's go to the script we wrote in the former lesson. Open that up. And the thinking here would be that every time an animation event is calling the footstep audio function, we wanted to call a random audio clip from an audio clip pool, or what we're going to use, an audio clip array. So in C#, we just have to add those square brackets near our audio clip variable. And that literally means that right now we're having an audio clip array that is called run clip, or we're just going to call it run clips. So right now, we just created the pool where we're going to just like fill in all the audio clips we want to call. But as you can probably see, we already have an error here because right now we're telling the locomotion source, audio source, to call the audio clip array, but we're not specifying which clip to call from that array. Just so you will have like, a better visualization of how it actually looks like. Let's go back to Unity. And right now you will see that the run clip turns into some kind of an array. So I can open that up and it tells me the list is empty. Let's lock this inspector here. Go back to our footsteps and just select all of our audio clips assets and just drag and drop them over here. So right now we're having an array with 4 audio clips that relates to the footsteps. And we need to tell the audio source to which audio clip to actually call from this array. Now, as you probably know, we don't want to call a specific audio clip. We want to tell C# to select whatever audio clip it wants, just like, call it randomly. So we're going to keep the locomotion source.clips equal the run clips. And then we're going to open a square brackets and we're going to write down random.range. Open another bracket and you can see it already completing me, where he's putting like the first value as 0 and the second value as the run clip.length. Now, before we're actually going to type them down, I want you to see that whenever I'm writing a function in C#, C# will already suggest or will tell me what kind of values he was looking for. So here, under this random.range function, he looks for a minimum value of type float, which is just a number for our case right now, and a maximum value. So our minimum value is going to be 0, and in a second I will explain why 0 and not 1, and our maximum value would be whatever the length of the array is. So we're going to type down run clips.length. So right now, it doesn't matter if I later on add 2 more audio clips or subtract 1 audio clip from the array, it's still going to call whatever audio clips we have in that array, because the length of the audio clips in that array will be the maximum number every time. Now, the reason we're using 0 is because that if you look here, our elements counting starts from 0 and not from 1. And it's a general rule of thumb in C#. I don't know about other scripting language, but in C#, the first element in your array or list or whatever will be 0. Like you just start counting from 0. So our actually footstep number 1 is going to be element 0 and footstep number 2 is going to be element 1. Like it seems like we're having 3 elements in our array, but we actually have 4 because, as we said, we start counting from 0. So right now we're telling the audio source that whatever the footsteps audio functions be called, look for a random clip from that array, select that, and then play that audio source to that random clip. And the debug.log gonna help us actually see which audio clip from that array has been being called. So let's check that out and see if it all works out. Compile, go. Okay. So cool. You can already see in the console that is like, it's like all this random counting for different audio clips, for different footsteps. Whoopa. Don't fall there. Okay, cool. So right now we're actually calling a random audio clip from an array of footsteps clip, which is quite cool because here we took another big step into making a really adaptive and elaborated audio system for our game just by using simple scripting snippets. But you would probably still hear that footsteps sound cut off each other. Like whenever there's a new footstep sound playing, we're cutting off the former footstep sound. And not speaking of like, the jumping and landing, we just cutting it mid-air. Okay. So we're gonna fix that now. And in order to do so, we're gonna use a different function that is not play, it's the PlayOneShot. Now, generally in Unity or in C#, there's several ways you can actually play an audio clip through audio source. The two main ones, though, are the play and the PlayOneShot. You also have play schedule, the play at point, and you have all kind of playing systems, functions, sorry. But play and PlayOneShot will be our main ones. Now, the audio source.play, just to, again, visualize it, will look something like that if you're trying to, like, imitate it inside a DAW. You see, like, the first audio clip, and the second audio clip plays, and then the third audio clips play. And whenever a new audio clip is playing, it's cutting off the former audio clip. Now, this is just how the audio source.play function gonna act. It will always cut off the last playing audio clip if it's still playing while we're calling a new one. Now, that's really a good case for a lot of stuff that we want to make sure about them that they're not gonna play overlapping or they're not gonna play twice. And if, for some reason, we're calling the same audio clip twice for that audio source, we want to make sure we're cutting off whatever is playing and we're like playing the new thing isolated with no other audio clips overlapping that audio clip. For example, it will be very good for the background music, for ambiances, where again, we want to make sure there's only one of those audio clips playing at the current time. Or think about the situations like when you go talking to some kind of an NPC and he has all those dialogues that you can just like skip through, just like, pressing X or A or whatever. And every time you're skipping a snippet of dialogue, the character immediately jumps to the next dialogue. You don't wait for it to finish, or you don't actually will hear them like, overlapping different dialogues. That will be a very terrible and just chaotic situation for the sound. So audio source.play is a really safe and dummy-proof way to make sure that whenever you're playing a new audio clip that's related for that dialogue, for example, you will always cut off the former playing audio clip. Now, the audio source.PlayOneShot, on the other hand, as you can see once again in the illustration here, will allow audio clips to overlap one another, and it will not cut off the former audio clip. Now, there's no better function here, it just depends on your needs. Again, the PlayOneShot function will usually be used whenever we want to play some rapid paced sounds, stuff like, footsteps and gunshots and UI. All of those sounds that will probably overlap, and we want to allow the player to have like a seamless experience whenever he's playing the game, because again, he may just like, shoot his gun all over the place, or just like, run and jump and do whatever, and you don't want those sounds to cut off. Now, as you probably see, in audio source.play, it will play whatever clip is associated with the audio source. Like if you remember, we didn't really have to associate a clip to that audio source. We only did it because we wanted to have like a dynamic system in our code. You can actually just play whatever is associated with that audio source. But for PlayOneShot function, you always have to pass in some kind of an audio clip. Now, I tried to look up for the reason why it's that the situation. I didn't find any very persuasive answer out there, but the best answer I found is that audio source.play is actually how you want to play and use your audio sources according to whatever documentation in Unity to whatever version. And the PlayOneShot function meant to play, again, short, unimportant sounds that are not supposed to cut off what is currently playing, and it's not supposed to cut off the whatever is being played through that audio source using the just.play function. So it just meant to play rapid, quick sounds that are not supposed to cut off anything. Now again, it seems weird for me because those are two very basic and main ways to treat audio in your game, which one keeps you dummy proof for no overlapping sounds and the other just allows you to overlap sounds. So yeah, those are the two situations. Now, PlayOneShot will obviously be the function we actually need to use here. So let's add that to our code here. So in order to do it, we're first gonna change that function into PlayOneShot. And you can see we're already having an error because, as you probably remember, we need to pass in a clip. So we can actually just take this snippet here because it just says go to the run clips array and choose a random clip from that array between the range of 0 and whatever the length is. So we can just like cut and paste it here and comment that out. And right now this code will work perfectly. You see we have no errors, and that's exactly what the PlayOneShot was looking for. But right now we won't be able to inspect it in our debug.log because we're not saying what the locomotion source.clip is. We're just telling the PlayOneShot to choose whatever clip it has, and like you get the idea by now. So we're actually gonna treat it a bit differently here, and it's gonna be a bit of codish, but bear with me, I bet you're gonna understand it. So this is what's gonna happen. Every time the frame on the animation event is gonna be called, and it's gonna call that footsteps audio, we're gonna call a new audio clip variable that's gonna be called clip, and that clip is gonna be equal to that run clips random.range and 0 between 0 and the run clips dot length. Cool. Wait, let's refactor that because there are too many unnecessary things here. Cool. So what's actually is happening, I am saying whenever this specific function happens and only when the footsteps audio function is being called, there's going to be a new variable of type audio clip that is called clip, and that audio clip variable is going to be equal to whatever random audio clip C# decided to call from this audio clip array. And then, inside the PlayOneShot, we're going to call that new variable that's called clip. And over here in the debug.log, I wanted to print out whatever is clip. Cool. So whatever audio clip this new variable clip is equal to, I want the debug.log to show it and the PlayOneShot to play it. If something here is not understood because it's a bit too, I don't know, abstract or something like that, or codish, feel free to ask me questions and question over whenever you see that. That's fine. Don't worry about it. So yeah, let's check that. Oh, you know what? No, before we checking if that's going to work, let's change all our function to the PlayOneShot because we want to allow them all to overlap if we need so. But in those cases, because we don't have arrays for the jump and landing, we can just literally call this jump clip. And we can cut that out. And over here, we're going to call the land clip. Now, right now, again, the debug.log won't be able to show us what the locomotion source.clip is because we're cutting that out also for the landing. But it's kind of fine because I don't see why we will be confused about what just played. Like literally the landing audio is a fart and the jumping audio is a ruler twang. So I'll think we'll be able to understand those. In any case, let's go back. Cool. And let's see if it works. Play. All right. Sounds are not being cut off. We're calling randomly whatever audio clip from that array. And it doesn't matter, again, when we're jumping, when we're landing, or when we're running, or how fast we're running, all of our sounds are overlapping, which already makes our system way more believable and way more slick. And more, again, audio pleasing wise, if that's the way to say it, for the player. So yeah, that's again the PlayOneShot for you. There's no better or worse kind of function. It just depends on your needs for that specific game. So yeah. Now, that was our first problem to actually, avoid our second problem, to avoid all of those overlapping sounds. And our first problem was to make it a bit more like interesting and realistic. So we solved it halfway by calling sounds from an array, But let's take another step further, and whenever we're calling one of those sounds or one of those functions, we want to randomize parameters of the audio source. Now, it's a very basic concept in game audio. Again, you always have to think about optimization of your memory, your runtime and hard time memory. And one of the best things to actually do it, or one of the best ways to actually approach it, is to make sure every time you're calling one of those sounds that's supposed to sound different every time, like steps for our example, in our case, we want to randomize the pitch and the volume just a bit to make the same asset sounds a bit differently. Now, just think about it like that. Otherwise, you would have to drag in 10 sounds for the footsteps and 10 sounds to the jumping, and for the landing, and for all other sounds you have in your game. And you're quickly going to clog up your memory, which is, again, the most inefficient way to actually work here in our scenario. And again, it doesn't matter if you're working on a small scale or a big scale game. It's always going to be true that you will need to keep your game as optimized as possible. And again, audio is going to be a heavy chunk of memory usage. So instead of doing that, we're just going to use 4 audio clips for the footsteps and 1 audio clip for the jumping and landing. But each time we're going to call them, with a different pitch and different volume. And by that, making it sound like we're having a game with a ton of assets, because every time we're calling one of those sounds, it's going to sound a bit differently. And the player won't pick up that it's actually just the same audio clips playing, or just a few audio clips playing. For him, it will just sound like, again, we have tons of assets in our game, and the game will sound rich and just more pleasing, in my opinion. So let's go right in and do that. So what we're actually going to do here is we're going to write down serialized field, and we're going to declare a new variable of type float. Now, float or floating point number are just a way in C# to represent a decimal number. That means that unlike whole numbers, that's how you say it in English, I think, like integers where we only have 1, 2, 3, 4, 5, 6, 7, 8. Here we have a decimal number with a floating point. So we have 1 point something, something, something. And we can have several numbers in front of that point or after that point. So yeah, a float in C# will just represent a decimal number. So we're gonna declare a new variable of type float, and we're gonna call that float min pitch. And that number will represent, the minimum pitch we're gonna have for our locomotion system. Let's duplicate that and call that, you guessed it, maximum pitch. Let's duplicate both of those. Control and Enter V. And that will be min vol, and that's gonna represent the minimum value for our volume. That's gonna be max vol. Wait, let's take out this H. Cool. Let's go back to the inspector so you can see what we actually did here. Max val. We'll fix it, don't worry. So right now we open 4 different floats. This is where we're gonna dial in the numbers for our different values for the pitch and our volume. So let's go back into C#. And over here, let's go over our logic again. Whenever a frame and a specific animation is gonna call this function, the footsteps audio function, we want C# to choose a random clip from the run clips array, and we want the locomotion source dot pitch to be equal to a random range between those 2 values of the min pitch and the maximum pitch. Let's duplicate that. And we also want our volume to be equal to a random range between the minimum value float and the maximum. Wait, and we need to change that val into vol. Cool. So right now, whenever this function is going to be called, it's going to choose a random clip. It's going to choose a random value between those 2 parameters. And it's going to choose a random value for the volume as well between those 2 parameters. And then it's going to play the clip. Let's copy both of those and paste them here, because I also want those numbers to be selected for whenever we're jumping or for whenever we're landing. Let's go back. Cool. And if you remember from our first lesson, we said that the pitch in the audio source starts on 1, where 1 will represent our, just the audio clip as we exported it, and 2 will be playing the same clip twice as fast and an octave higher, and a 0.5 gonna play it an octave lower and twice as slow. So the minimum pitch, I think, will be 0.8. That will be a good start. The maximum pitch will be 1.2. The maximum volume can't be any more than 1, so let's keep it at 1. But our minimum volume will be 0.7. Let's save that up and let's see how it sounds like. Play. Cool. So it's obvious when we're jumping and landing. Just listen to it. Cool. Now, whenever we're changing one of those parameters, right now we don't see them changing on the audio source here. And the reason is because we're just looking at the prefab. But if we will look on the actual game object that's right now inside our scene, you will see that the audio source will always have changing values. So you can actually inspect what's happening every time we're calling one of those functions. And also, we can fine-tune now our sounds. Like, let's say we want to check if the min pitch can be 0.175, and the maximum will be, I don't know, 1.45. Yeah, let's take it to the extreme. Cool. It kind of works with the footsteps and not with the jumping and landing sounds. And if we want to have, like, different parameters for the jumping and landing, we can just type in our, random.range the actual numbers we want, or we can create new float parameters for our min pitch, for our jumping, min pitch for our running, and you get the idea here. But for now, that's gonna actually do. And you can also just get crazy with it if you want to just check what happens if it goes crazy. For whatever game mechanics you want to add here, that's can be cool. Let's see what happened when I jump. Amazing. Beautiful. Gotta love audio. It's just it's beautiful and funny at the same time. In any case, you will see that right now, whenever I'm gonna exit the play mode, all of my values are gonna go to where I started. And that's actually good that nothing actually been saved up, because as you can see, it's easily to get tempted to just play around with those parameters, and then you exit the play mode and you're like, oh shit, what was my initial parameters? But what you can actually do if you like what you did during play mode, you can just literally right click here on the script and copy component, and then when you paste it, just paste component values. And then you will keep everything you changed and it will be, beautiful. So yeah, this is how you can just randomize parameters. Again, very basic parameters for when it comes to more an adaptive audio system, like the pitch and the volume. You can play around with tons of more other stuff, I don't know, even with EQ or whatever, but again, it's a bit more in-depth here. But in general, it's always a good practice as a in-game audio, to try again to optimize your memory as much as possible, and playing around with different parameters for different audio clips can be really an efficient way, as you saw, to keeping our game to the minimum usage of memory and to the maximum, again, audio quality, or the way the game actually sounds. Now, the last thing I actually want to touch on is just dynamically changing all of those functions and routing all of those different audio clips that are being played for the audio source to the audio mixer. Now, if you remember from the first lesson, I always said you always have to route your audio sources to your groups as you start, because otherwise it's just gonna be a mess. So yeah, let's do that, and let's not skip this part of implementing audio, because you do want to have control on your locomotion. And as you probably heard, the jumping is a bit too loud, and the footsteps, I don't know, we can play around with their EQ a bit. So let's do that now. Now, if you remember, on the former stream, we talked about namespaces. And whenever we want to access stuff that are audio mixer related, we actually have to open the using Unity Engine.audio namespace to reference all of those stuff that is relevant for our audio mixer. So we can just type in using Unity Engine.audio. Cool. And right now, if we'll type down serialized field and delete all of that, and we're going to type down audio mixer group, you can see we can access those variables that related to the mixer, like the audio mixer group. But I don't know from which version they actually started to making this amazing thing. We don't actually have to add the namespace. So we can just type down the serialized field and all these beautiful shenanigans. and type here the audio mixer group, and you will see that C# will already suggest this namespace of like, hey man, you should probably add the using the Unity engine.audio, and you'll be like, cool, and just press tab, and you will see it just added it to the namespaces here, which is again another small step to keeping us all a bit more dummy proof, which is great. In any case, we declared a new variable of type mixer group, and we're gonna call that the footstep group. Cool, let's duplicate that, and that audio mixer group is gonna be called the jump group, and let's duplicate that, and that one is gonna be called the land group. Cool. And let's go over our logic once again. Whenever a specific frame on our animation is gonna call one of those functions, let's say the footsteps audio function, we're gonna choose a random clip from this audio clip array. We're gonna access the audio source pitch and choose a random value between those two parameters. We're gonna access the locomotion source, audio source volume, and choose a random value between those two parameters for the volume of the actually played audio clip during that time. And whenever this function is being called, we're gonna route the locomotion source output into a specific group, in this case to the footstep group, and then play that clip. And same goes for the jumping. We're gonna randomize those beautiful parameters and type down the audio mixer group, and this one is gonna be equal to the jump group. And now we can just like copy and paste it here, and that's gonna be called equal, to the land group. Let's go back to our, wait, let's delete this not pretty gap here and save it. Sorry for this mess. Cool. Let's go back, and right now you can see in our inspector, we open new tabs that are looking for audio groups. So we can just like click the circle here and choose the audio group we want, or we can just like drag and drop it. But yeah, first of all, we need to open those groups. So let's minimize that, and under master, we'll add a new master group called RedRunner. And under this group, all of the subgroups will be related to the RedRunner. It's going to be our locomotion like right now, but it's also going to be the def sounds and other stuff if we choose to add. And under RedRunner, we're going to add the footsteps, duplicate, that's going to be jump, and duplicate, it's going to be land. Cool. So right now on our RedRunner, we can just literally drag and drop those groups. And now if we'll press play, you will see that, you will see that each of those locomotions, I've been to a Metallica concert, like a tribute yesterday, and for 2 hours I screamed like, yeah, James Hetfield. So you can hear on my voice, I'm a bit weak. So yeah, in any case, let's still mute the music and the ambiances. And now whenever I'm walking, we're playing through the footstep group, and the jumping is playing here, and the landing is playing here. And now I can just like beautifully mix it the way I would see fit. And again, this is where us sound designers actually shine. Like all of that shenanigans is super important, but this is where it's actually our job to nail it properly, because over here, again, we just like, we worked on the system a bit and we coded a bit, which like, programmers and game designers can actually do. But over here, this is where we mix our things. And we just took care of that, situation where we can actually mix all of our different sounds so far and other sounds in the future that we'll add to this game. And we can literally mix it during the game mode. So let's take it all out of mute. And I'll be like, okay, we can hear the footsteps. I think the birds are a bit loud. Okay. Jumping is a bit loud as well, to my taste. Still. And landing. Landing is fine. Now, another cool feature of the mixer, we can see here, if you listen to the footsteps, I don't know what about you, but I feel like there's way too much low mid in those footsteps, especially when we're talking about such a squishy, small little character here. So in real life, I will just re-export those footsteps but just for the sake of it, let's actually look at it. So what we can do, we can just go to the footsteps group here. Wait, let's take that lock off. And we can add an effect, and let's add a high pass filter and cut off everything under, I don't know, let's start with 650, it sounds good. And already my footsteps sounds a bit more fitting that character, but I think we can just like still a bit more mids here. It's still a bit more mids. No, that's too much. Okay, let's hear it in mix. Now I think we can actually cut it a bit more. Okay. And right now, those sounds, those footstep sounds way more fitting that RedRunner character, at least to my liking. And yeah, I think because footsteps in general, it's not supposed to be such a prominent sound. So we should actually hear it properly, but it should go to the back of our mind after we're playing several times, because we don't want this footstep to always like chuck, 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 chuck in our mind. So I think the mix right now is quite fitting. Let's see how we continue on after we adding more elements. Yeah. Now the cool thing about the audio mixer is that the changes actually stays after we exit the play mode. That's unlike different parameters that it relates to literal game objects in the hierarchy. So yeah, everything you actually mix during your gameplay, you don't have to remember like for later. Unity is gonna keep your mix after you're done mixing. Now the last thing we want to do, again, as we're talked at least so far in our first and our second stream, is about keeping all of our space and our tools tidy, clean, and understandable for us in the future and for other team members that's gonna, I don't know, somehow connect to our work or wanna like, you know, look at our work or whatever. Let's keep it as understandable as possible. The first thing we're gonna touch here is coloring our groups. Now, develop your own method for this one. This is gonna be my method. In general, because we're always gonna have a master group in every mixer, usually I just tend to keep it just like this, like uncolored, because usually I won't touch the master fader here, unless I'm doing like a real global actions here, but usually I won't touch the master fader. Now, every master group, like the ambience, the music, and the RedRunner, is gonna be painted red. So every master group I'm gonna have in this game, also like, you know, after, is always gonna be red. But wait, one other thing I like to do is to keep the music group always as the bottom here in the view. Never mind, it's like my own thing. Now, every other subgroup that is related to some kind of a master group is gonna be painted with one color. It doesn't really matter which color. It's just a matter for me to be able to actually visualize that mixer and instantly understand which groups belong to which master group and what they control. Now, I know the RedRunner demands to have a red color, but we're not going to do that. We're going to choose the yellow. And for the birds, which is related to the ambience group, we're going to choose green. So right now, whenever I'm looking at the mixer, I immediately know which group controls what, and I don't really have to read it, or at least not for the first encounter I have with the mixer. Now, to take it even a step further, we can use the views here. Now, in general, whenever I'm viewing all the groups, I like to call that view the all view because it's all of the groups view. And let's add another view, and we're gonna call that the master view. And under this view, I will only be able to visualize the master groups I have in my game. So right now, whenever I'm looking at the master view, I can make like, you know, again, global changes for different groups, so I can just like, you know, access different parameters if you want to connect them later to C# to have like, again, an adaptive audio system, which we're going to look at way later. And let's add another group, and this group is going to be a view, and this view is going to be related only to groups that is related to the RedRunner. So let's take out the music and bring back the land and jumping and take out the ambience. So whenever I'm looking at the RedRunner view, I can just like mix and treat the group that relates to the RedRunner. So I can have the all view, the master view, and the RedRunner view. Now, one thing I haven't touched, which is actually really important to talk about, related to the groups, sorry, I just like forgot about it, You're probably wondering that whenever we're changing a sound, like, the Red Runner is running and we're playing all of those audio clips through the footstep group, but then we're jumping and we're playing the jump sound from the jump group. Now, does it actually sends the audio clip to that group and keeps it there? Or let's say I'm gonna have, like, I don't know, the ambience playing in that dynamic system, and I'm changing the group to some other, I don't know, group because of some other function that is being called. Will this long file of the ambience will be played from the new group now? And the answer, sadly, is yes. If I'm gonna use that system for long sounds and not short and rapid sounds, I'm just gonna start switching groups for the same audio clip. So this is quite bummer because it means that this dynamic group routing system is not gonna be relevant for those long sounds. But in general, usually we're gonna have, like, again, those basic long sounds just inside our hierarchy for their own respective audio source is gonna be routed where we need. But nonetheless, the system will work whenever we're playing rapid sounds. As you heard, I can literally just mix those different groups between those different elements, and it all sounded just fine because they doesn't really manage to route anything with importance to the other group. Now, that's important to keep in mind here that it will be true as long as we're not having, like, an extreme process of one of those groups. Let's say I'm gonna have, like, a compressor working in insane values that all of a sudden, if I'm playing the footsteps sound into the jump group, like, my sound will just, like, blow up for some kind of reason. But because all of our groups here are supposed to play close sounds related to locomotion, they're supposed to have the same levels and nothing, you really have, like, a process here besides the EQ. But again, it doesn't really affect the sound because those sounds just played under than a second, like, length. At least for the body of the sound here. So yeah, the system works in our case. Now, the other thing we can do to make our system cleaner, or just like, our workspace cleaner, I'm going back to where I stopped, sorry, is actually to make that script way more understandable. Again, for us in the future and for us tomorrow when we come back to work on this project, just to have it a bit more cleaner. And for, again, other team members that's gonna look at our script or if they wanna mess around with values or whatnot. So just to make it a bit more understandable, we're gonna add headers. Now, headers are just gonna be, again, headlines that will appear in our inspector. So in order to add a header, we can just open a square brackets, type down header, open normal brackets, and type in a string. Now, in C#, whenever you're typing text between two quotation marks, and you can see it's already red, for this example, it's gonna be just audio sources. It's gonna be the header for the audio sources. That means that literally the text that is living between those quotation mark is gonna be regarded as this text with no other sub-meaning to it. It doesn't represent some kind of variable. String is just a way for us to pass in a series of characters or text, in other words, into C#. Let's say that if I will be adding here in debug.log hello between those two quotation marks, whenever this function is gonna be called, I'm gonna see the hello inside my console. So yeah, those are strings. It's just a way for us to input any kind of text that we want to be regarded as the text we typed in. Cool. Let's copy that. Let's enter and paste that, and those are gonna be our audio clips. Cool. Let's copy that, enter, paste. And those are gonna be parameters. Cool. Let's copy that and paste. And those are gonna be our mixer groups. Cool. Let's go back to our inspector and look here over the script we're having, and you will see we're having titles for all of our different elements. So right now, whenever, I don't know, some other developer is gonna look at our script, it's gonna be very easy for him to understand what he's actually looking at. Like, oh, okay, this is where we're having audio sources, this is where we're having audio clips and parameters and mixer group, cool. And then if we're like, using some kind of this script template and all those variables will be empty, again, it will be really easy for us to understand which element we should drag to which slot here. So yeah. You can take that inspector fine-tuning really to the edge. You can add colors and underscores and turn values into sliders There's a whole YouTube's videos about it. You can deep dive as much as you want. But in general, it's a good practice at least to add a header to make it, again, understandable for everyone in your team. So yeah, this is it for this stream. We just took our locomotion system one step further and make it way more game audio wise when it comes to how rich our system sound like and how efficient it is actually when it comes to how much memory it actually uses. Now in the next stream, we're gonna solve our last bug, which, wait, let's solve our locomotion source. Group, sorry. And you will see that if we jump, we're still playing a footstep in the air. Listen good, carefully. Now the reason is because there's probably some kind of an overlap or like a crossfade between the two animations of the running and the jumping. So there's still like an animation event being called from this footstep, from this run animation, sorry. Now we're actually gonna solve that. It's gonna be a bit of codish, but again, don't worry about it. As you see, once you understand the gist of it, it's not so hard, at least in this level when we're talking about programming. So we're gonna solve it like that. And afterwards, we're gonna talk about Unity events and how we can add sounds to all the different UI elements in our game. So once again, thank you for joining this video. It was a pleasure. Goodbye.